Today we are going to integration by inspection. It means how can we integrate? By just inspecting the nature of what we are given. But note, by inspection usually come in form of quotients. I mean fraction, one, maybe something over something. So now, the standard definition says if you are given integral of f prime of s over f of s dx, which means if you differentiate this f of x, that is f prime of x, if you differentiate f of x and it gives you f prime of x, it means the answer will be ln of f of s. It means if the differential, don't forget you are dealing with integration, but for inspection, if the differential of denominator, it gives numerator, then the integral of the question is ln of denominator. Ln means log of base e, which is ln, note, ln means log of base e, log of base e. Ln means log of base e. So this is just by, you just inspect, then you have your answer. It's not hard. So let's go to these examples. Find the integral of the following. Number one, let me start from number one here. Solution. It's very easy. Number one, we are given what? Integral of what? Of 4x what? Cube minus 1 over what? X raised to the power of 4 minus x plus what? Plus 2 dx. The answer will be what? Now, just look at the question. If you want to test, just differentiate denominator if it will give you numerator. By looking at this, if I differentiate s raised to the power of 4, it will give me what? It will give me, if I differentiate, you can just write it somewhere. If I differentiate the denominator, if I differentiate x power 4, it will give me 4x power 3. That is 4 times. Everybody can differentiate now. We've go and check my previous video. I've explained the concept of differentiation. So the differential of x raised to the power of 4 will give us 4x power 3. Then minus, if I differentiate x, it will give me 1. 2 is a constant, which means when I differentiate denominator, I get what? I get 4x cubed minus 1, which is equal to numerator. So the answer of this will now be ln of denominator, which is what? Ln of what? S raised to the power of 4 minus what? Minus x plus what? Plus 2. X raised to the power of 4, that is, the answer will now be ln of denominator, since the differential of denominator gives numerator. The integral of that question will now be ln of denominator, ln of x power 4 minus x plus 2. That is that. It's very easy. Just inspection. Number 2, we are given integral of 3x squared over x cubed plus 1 dx. If you want to integrate this also, okay, how can you know that this is inspection? Please, once there is a fractional part, first try if it will go by inspection. Okay, I want to test if by inspection I can integrate. I want to test the nature of denominator. If I differentiate denominator, if I differentiate x cubed, it will give me 3x squared. Differential of constant is 1. What is here? 3x squared, which means differential of denominator gives numerator. So the answer will now be ln of what? Of what? Of denominator, which is what? X raised to the power of 3 plus 1. Plus your c, don't forget your c, plus, there must be plus c after integration. Number 3, as you can see, is not hard. Just observe if the differential of denominator gives numerator, then the answer will now be ln of denominator. So let's go to number 3. We are given integral of what? Exponential of 3x over exponential of 3x minus 1. Now let's see what will happen. If I differentiate denominator, I'm given exponential of 3x minus 1. If I differentiate, it means dy dx. It will give me what? If I differentiate, this one is a composite function. The shortcut is, if I differentiate 3x, it will give me 3. that 3 multiplied by the exponential of 3x back, it means I've differentiated this. The shortcut says, normally I'm supposed to use chain rule. So but I've taken the shortcut, differentiate what is here, 3x. If I differentiate 3x, will give me 3. Multiply it by the question back, 3 exponential of 3x. If I differentiate constant 1, 0, which means when I differentiate denominator, it gives me 3 exponential 3x. Now, let's look at this and this. They are not similar, but they are somehow similar. It means thrice of numerator. Thrice of numerator. Now, there is a logic here, and you have to be careful. For here now, since the differential of denominator gives thrice of numerator, because this is thrice of numerator, then there's a question: how can I make this to be this? How can I make this to be exponential of 3s? What can make 3 exponential of 3s to be exponential of 3s? Is to multiply it by what? 1 over 3. Because if I multiply this by 1 over 3, it will give me, because 3 will cancel 3, which means my answer will now be, since if I multiply this, my answer by 1 over 3, it will give me the numerator, because it must give me the numerator, which means the answer will now be 1 over 3, because of the 1 over 3 that will make it to be exponential of 3s, it will now be 1 over 3 ln of denominator. Ln of what? Of exponential of 3x minus 1. I explain again. I differentiate denominator, I have this, which is thrice of numerator. What can make these 3 times of the numerator to be exactly numerator is to divide it by 3. And dividing by 3 means multiplying by 1 over 3, so that it can be this, which means for me to multiply by 1 over 3, which means the integral will be 1 over 3 of ln of what? Denominator. So I move to question number 4. Just time, why you do so table? Done by next I'm done. Question number 4. Integral of what? Tan x dx. If I want to integrate tan x dx, you cannot integrate direct. If you are given integral of sin x, you can have your answer direct. They are standard. Integral of cos x, they are standard, and others. But there is no standard integral for tan x. So due to the logic or due to the knowledge of trigonometry, note that what? Tan x is equal to sin x over cos x. So I will now make this tan x to be in form of nature of quotients, because there is no standard integral for tan x. It will now be what? Integral of what? Sin x over what? Cos x what? Dx. I'm still writing tan x in another form. I can now integrate. Now I want to inspect. Probably if you can go by inspection. But I want to inspect denominator. If I differentiate cos x, it will give me minus sin x. If I differentiate cos x, which means d dx of cos x give me minus sin x. Although it is similar to numerator, but there is a negative. Due to the negative, what can make this negative to cancel is to multiply by negative. So because of the negative, what will now happen? So my answer will now be minus, because of the negative. Because by the time I multiply this by negative, it will give me sin x back. So it must be minus ln of denominator, minus ln of cos x, plus c. There is plus c here, plus c. Well, if you stop here, you are correct, partially correct. But you cannot see your answer in objective. You can never see your answer in objective. I'm very sure we understand. If I differentiate cos x, it gives minus sin x. But it's supposed to be numerator, which is sin x. Now, what can cancel minus is to multiply by minus, to make it to be exactly sin x. It will now be minus ln of denominator cos x plus c. Now, according to law of logarithm, note that ln, I've said it earlier, ln of x means log of x base e. Ln of x means log of x base e, which means I can still write this as what? I can still write this as minus log base e of cos x. It is not compulsory. It's not compulsory like this. It's not compulsory. It can be like this. Just showing that it can be like this. It can be like this. I'm still writing the same thing. But there is a negative here. According to law of logarithm, the negative will now come to the front. According to a particular law in logarithm, let me write the law here. The law says if given n log a base b, the power n, sorry, the number n will come to the front. It will now be equal to log what? Log a raised to the power of n base b. So I will now apply that law here because there is negative here. So the negative will now come to the front as power. So the answer will now be equal to minus, it will now be log of what? Cos inverse. Because, okay, I can just write, although ordinary minus means minus 1. Minus 1 is still minus. So cos inverse of what? Of base E plus what? Plus C. But note, as you can see, I'm just branching into many concepts. Note that cos inverse of x, there is x here, sorry. Cos inverse of x means 1 over cos x. Note that cos inverse of x means 1 over cos x, which means this is equal to log, it can be lean, don't forget, log of what? 1 over cos x base E plus C. Well, you can't still stop here because you now recall again. You recall. That's why you must have basic knowledge. So recall that 1 over in trigonometry, 1 over cos x is equal to sec x. Sec x. 1 over cos x is equal to sec x, which is seconds. We call it seconds. So the final answer will now be what? Log of what? Sec x. Since 1 over cos x is sec x, base E plus C. Or if you like, you can just write your answer as ln. Same thing. Ln of what? Sec what? Sec s plus what? Plus C. That is the answer for question number 4. Let's go to question number 5, which is the last question. Question number 5, the last question. Integral of 4x plus 6 over x squared plus 3x dx. Now, if I want to integrate, I want to inspect, integration by inspection. If I differentiate this, it will give me, if I differentiate denominator, it will give me 2x for this. If I differentiate 3x, it will give me plus 3. Although it is similar, it is somehow similar, but if you observe very careful, you will see that this my answer is relating to numerator by 2 times. Which means if I multiply this by 2, what will happen? It will give me what? 4x plus what? 6. Which means I can now conclude that differential of denominator is twice numerator. Because if I multiply it by 2, it will give me numerator. Since 2 times the differential of denominator gives numerator, then the answer will now be, since it is 2 times, 2 ln of denominator. Because if I multiply the differential of denominator by 2, it will give me numerator. And it must give me numerator. It will now be 2 ln what? X squared plus 3x. Then don't forget your what? Plus C. As simple as that. Thank you very much for watching.